Okay, we're ready to put this together. So I got the hardware out. Now we have the lock washers I can't stand using, and then we have the good nuts. So we're going to use these, leave these lock washers out, or we're going to use them. And we got our clips here to go on our pistons. We got to put those on. The carburetor has to go on when the cylinders go on, which are over here. So all of this stuff has got to be put together all at one shot. And we need to do a little bit of cleaning on these, and we need to do some ring fitment. We got a lot of stuff to do. This is a big job now. Half the motor goes together all at once. The upper half. First thing I'm going to do is clean the cylinder off. And my fingers don't fit in here like I used to. When I was a kid, I could put my hand in here. That was a long time ago. The many years of abuse of torque in my hands have made them bigger, so you don't fit in there no more, and they don't bend like they used to. So the CRC loosens it up. See how there's no black or gray on there? Because I probably already cleaned these. Just to make sure we're going to do it again. So you take your semi-clean rag. That'd be this one. Wipe out the bore. And these are very sharp on your fingers.
When do we put oil in?
Before they go on the motor. Where's that other clean rag I had out? Is it laying over here somewhere? Purposely brought out a clean rag. There it is. Look at that.
Wow.
Don't have very many of those pieces around here. Need one more layer of the CRC in here. If you want to know what I'm using, it's that.
Multi-purpose lubricant and corrosion inhibitor.
That's right, we're corroding the inhibitor right now.
We're inhibiting it, huh?
See, no black. These cutouts are hard on my hands. I look like that, see? Nice and clean. You did such a good job on that one, guess what? Got another one to do. At least our CAD plating hasn't corroded yet.
It's a good side.
Yeah. Special clear coat's holding up. Sharp over there. Something was. Get that chamber LD bird in there. Something over there got me. All right, that good and clean for you now? Okay, now, let's check our rings. Put them in a hole. You can use your fingers to line them up like that, or you can take your piston over here. See how it's a flat top. Go like that. Check your gap. It appears this is going to be a file to fit motor. See how tight that gap is? See, you're not going to get this in here, see?
How much clearance is there supposed to be?
I'd like to have at least this much in there. On my race bike, I have at least 9 thousandths. I think this has more gap than the O-ring. That's kind of backwards. So, see, it's not quite this. This is like 16. See, on a street bike, everything runs hotter, so you want more gap. But on these bikes, you need, like I said, you could probably be as low as 12 to 13 thou because the bore is so small. But the thing is, it runs so stinking hot. You need some clearance in the pistons and the rings or the stick. If the ring butts together, then it doesn't work. It locks up in the cylinder. The piston's still going to go up and down. So on a cheap piston, you can pull the ring lands off, or it'll make for a lot of blow by. It'll also scar the cylinder up as it goes up and down. So all of these problems happen when you don't have enough pressure, enough ring gap in there. Now, I've never seen my rings butt. I've never seen any marks, but I have a lot of broken pistons where the ring lands are all broken. And I think this might be more from the severe amounts of nitrous I run through the Flathead motor.
That might have something to do with it.
That's what I thought. Yeah. I figured that might be the reason. We never had the problem with the gas motors. Nitrous motors, there's those issues with them. Okay, this is our ring filer. So this is actually a diamond cutting wheel. So flip the other side. So you have to hold this in here, squeeze the ring in against these pins, push it in, it collapses it. You got to hold the ring flat, and you also got to make sure it doesn't twist. You can twist the ring where it goes like this, so make sure it sits square and flat. So when you line up nice, and you get a little bit of crank. Not sure how much to use, so we'll go with that much. Make sure you wipe the grit off the ring, because we don't want that in our clean cylinder. You can see how I ground the rings here. And that's like about a 30 grit finish. So they're obviously not into fine finishing rings around here on those. Okay, let's see how much more gap we have now in there.
Yeah. But not that much.
Not that much. Not sure how much we have though. What do you think you got?
Gosh.
About that much.
Well, somewhere in there, though.
One of these.
Yeah.
Yeah, what do they got over there? I'm thinking it's got like about, let's go with 11. It's got 11, barely. Is that 12? No. 12 I have to push in.
So it's got 11.
Yeah. So I'm thinking 14 to 15 would be your safe low side number. The formulas you can run a lot tighter. 2 more of those. This is my deburring tool. You push wherever you want to cut. See, it knocks off the burrs. you want to make sure you get all that grit off the ring. Do not file the edges here, that makes the ring gap bigger. And everybody does that for some stupid reason, I have no idea why. If you put a 20 thou chamfer on your ring, that means you have an extra 40 thou ring gap you just added. That defeats the purpose. And notice we're still on top of the cylinder. Go down deeper. Make sure you're all the way into the good part of the cylinder. Okay, what number you want? 13, 14, or 15? What do you mean you don't know? It's your bike. How hard are you going to get it? How hard are you going to drive it? Ride it. I ain't got no 14 in there yet. I think we'll go with 14 as an average. How's that?
Okay.
We have a 3 thou, we have a 3-inch bore motor, let's call it. And if you run 4 thou per gap, that'd be 12, right? That'd be like a race motor, 4 thou per inch of bore. Okay, 14 is just going in. So that knocks the burrs off. See the little burr right there? Takes it off, see? Okay, we'll double check it. It's a tight 14. After you put it through once so it wears in. It's a plug fit, it just fits in. So realistically, you're about 13 and a half. Okay, that's one ring. Okay, you're gonna do the next 5. You got a whole bunch more to do here. Appears to be a little tight.
Yeah.
Kind of matches the last one. Imagine that.
They make them all the same.
Very similar, yeah. I don't know what's up with that.
Did you count how many turns?
Did I put on it?
Yeah.
I used about 6. How many was that?
4.
There you go. See, that was 4 steady ones, not back and forth a couple. Appears to be tight. It's almost like we need more. How many was that? That's 3 more. Oh, geez, look at that. It's way too much. It's trying to go in, but not quite. Do it.
Mm-hmm.
14. Second ring. Now, the second ring you always want to run a little bit bigger than the first one. Looks like about the same tightness.
Yeah, it looks like it's touching.
So we went like 11, 12 turns, I think. I think it's 11.
Yeah, 10 or...
The But this is a softer material because this is cast iron. These rings here were some kind of a heavier coated steel thing, or it's still cast iron, but probably a heavier duty, stronger material. Usually means it cuts slower. Oh yeah, geez. Boy, did that thing open up. It's definitely bigger. Got way too much. So don't go so much in the next one. Don't have to worry about that being a back pressure on the ring. So you don't want pressure to build up to your two ring lands. So you always want to make sure there's room for the air to dissipate through. So you always want to run the second ring looser than the top ring. So it doesn't really hurt being extra clearance. And that's extra like the same as that one. So these are probably about, that's probably 15, 16. So we probably got about 19 on these, would be my guess, without measuring them. Which is more than they needed to be, but doesn't hurt. The second ring is mainly an oil control ring. It's not supposed to seal compression. The top ring is supposed to seal compression. Those two are done. Oil rings you rarely have to cut. In this case, yours are tight. Just like all the rings are tight, so. See that? Camera. See, it's very little gap. So normally you don't cut oil rings. Now these don't need to be much clearance at all because they're cold. You can probably run these at 8 thou and it would probably be fine. So we'll make sure they're at least 10. So it doesn't. Usually oil rings are way bigger than they need to be. Okay, we got at least 10. Probably got about 11 or 12. So I think that was 3 turns on these, so 3-turn deal. Production line. They make a power version of this. I don't know why you never use it. Imagine how much material you would take off with power.
They could do them all at once.
Yeah, that's not very safe. You could, but that's not a very safe way of doing it. You'd be asking for issues real quick. Okay. Cleaner part of my shirt. That's why I like all style shirts, they work better. I think this one's a Hanes though. It gets holes in it quicker. Like everything I wrote, I test my stuff pretty hard. Yeah, it doesn't look like it's 10. Yeah, it went in. Tight 10. 10's pretty narrow, so. Keep moving the damn ring down. The tightest one. This one here is pretty. It's the tightest one, so recheck it. Yeah, it's definitely the tightest one. we've got our clearance, but it's tighter than all the other ones, so it's one turn off. Might as well make them all the same, right? That looks a lot better. Now they all look equal. Whatever the equal is. Okay, so get all that done.